8 has given us two position vectors, but with trig in them. So this is quite an unusual question. Again, don't panic if you get an unusual question. We can cope with vectors and we can cope with trig. So there's no reason why this question is going to be any harder than any other vectors question or trig question. It just scares us when they combine two components. But as long as we know our trig stuff and as long as we know our vector stuff, then we should be fine. And we'll just deal with whatever comes. So this says that these two vectors here are perpendicular. And it also says that alpha is a value between 0 and 90. So the first thing to pick up on is the fact that the two vectors are perpendicular. And if any two vectors are perpendicular, then their dot product is equal to 0. So that's the first thing. We're going to say that the dot product of these two vectors is equal to 0. So let's find the dot product. And the dot product is going to be the x components times together. So that's going to be 3 sine theta times 2 cos theta. Sorry, it's alpha. So that's going to be 6 sine alpha cos alpha plus 2 cos alpha times 4 sine alpha. So that's going to be 8 sine alpha cos alphas. Let's do it in that order so that we can combine these more easily. Sine alpha cos alpha plus -1 times 3, so that's -3. So those three things added together is going to give us 0. So here we've got 14 sine alpha cos alphas minus 3 equals 0, so we could move the 3 over and set that equal to 3. Now the key to this question, I think, is knowing your double angle formulae and knowing that if you've got a sine alpha cos alpha, you can turn that into one of your double angles, and it's the sine 2x relationship. Sine 2x is the same as 2 sine x cos x. So usually in C3 we'd only be expected to use this to this. In C4 we're likely to have to be able to go backwards as well. So it's important that you know this relationship back to front, so that if you see a sine x cos x, you can turn it into a sine 2x expression. So we've got 14 sine x cos x, essentially, 14 sine alpha cos alpha. So we're going to times both sides by 7. So 14 sine alpha cos alpha is going to be equal to 7 sine 2x's. So we can now replace this with 7 sine 2x, or sine alpha, is equal to 3. This is now easy to solve. We can divide by 7. And find the inverse sine of 3/7. Inverse sine of 3/7 remember we're in degrees because it said that alpha is between 0 and 90, is 25.37, 25.4 to 3 sig fig. But don't forget, with the sine graph, we're going to get another value before we get to 180, and we need to go to 180 because we're working with 2 alphas, so we need to double the range that we're told, because we're about to halve these numbers. So even though the next number that I write down is going to be greater than 90, when we come to halve it, it will be within the region that we need. So if I take the 25.4 away from 180, I'm going to get another value of 154.6. So those are our two values for 2 alpha. Our actual two potential values for alpha is going to be these two divided by 2. Now don't forget to use the actual numbers on your calculator to divide by 2 so that you don't lose any accuracy. When you divide the full number here by 2, you get 12.69, so 12.7. and when you divide the 154 by 2, you get 77.3. So those are the two values you're looking for correct to 3 significant figures.